Yes. Postulates of special postulates of special theory of relativity. ಮಲ್ಲನ್ ಗೌಡ ಅಪಿಯರ್ ಆಗುತ್ತಾ? Okay, I'm going to what I'm doing now. Oh, very good, very good. Okay, fine, fine. Okay, yesterday we learned this is one the null results of Michelson-Morley experiment. So from the Michelson-Morley experiment, we have got this is one number of fringes which is shifting from the particular mark that is equal to 0.37. This is according to theoretically. This is according to theoretically. But actually practically, experimentally, there are no the number of fringes shifting by the particular mark which is equal to 0. This is we call as the null results of Michelson-Morley experiment. Based on null results of our Michelson-Morley experiment, or this is one a failure of Michelson-Morley experiment, this adopted by the Albert Einstein and made a special theory at the age of 26 by the Albert Einstein. That is we call as a special theory of relativity. So here, special theory of relativity, which is made by Albert Einstein 1905. So at the age of 26, the Albert Einstein age was 26. He made a special theory of relativity in 1905. So here, this is a special theory of relativity which is made of Albert Einstein to solve problems in one frame of reference moves with a constant velocity with respect to another frames of reference. So why the Albert Einstein made the special theory of relativity? So in 1905, Albert Einstein made the special theory of relativity to solve the problems in one frame of reference moves with a constant velocity with respect to another frame of reference. Why? Here, according to this is one Michelson-Morley null results, all motion, look at this, all motion are relative. Yes, this is the special sentence made by the Albert Einstein. All motions are relative. Actually, he is going to eliminated the initially what actually we according to classical mechanics absolute motion. Yes, this is eliminated by the Albert Einstein. There is no absolute motion. All motions are relative. Therefore, he made two special postulates by the Albert Einstein by adopting the failures of Michelson-Morley experiment. Those are, the first one is, so here according to Albert Einstein, all motions are relative. There is no absolute motion in the universe. Therefore, the first postulate, which is the laws of physics, are the same in all inertial frames. This is actually this is the very important statement. Actually, beginning of the class, I said this is one. The laws of physics are the same in all inertial frames. That means the laws of classical mechanics are identical in all inertial frames. This is we call as a Galilean principle of relativity. Diresh, are you listening my voice? Okay. Yeah, yeah, able to see in the board? Read it. What actually first sentence I made? This is one. Yes, this is the first postulate of special theory of relativity made by Albert Einstein. This is the retain of what is the this is one Galilean or Newtonian principle of relativity, that is says the laws of physics are the same form in all inertial frame. That is the first postulate of special theory of relativity. That so the second is the velocity of light. The second is the velocity of light. That means c is same value for all inertial observers, for all systems, for all inertial frames. So here the statement, the second postulate is the velocity of light is same value for all inertial observers. Yesterday what I said, the only the absolute quantity present in the universe, that is the absolute quantity, only the absolute quantity, that is the speed of light. The speed of light measured by the any observer, whether he is motion or a rest, the value of the speed of light is same for all observers. That is the velocity of light. The speed of light is same for all inertial observers. This is the second postulate of special theory of relativity. It is the of principle of constant of speed of light. This is the principle of constant speed of light. The first postulate is Galilean principle of relativity. The second postulate is the principle of constancy of speed of light. The first postulate says that the laws of physics are same in all inertial frames. This is the first postulate. The second postulate is the velocity of light is same for all inertial observers. So these are the two important postulates made by the Albert Einstein in 1905. This is maybe very important for 2 mark for exams. Mostly important is write the postulates of special theory of relativity. Write the null results of Michelson-Morley experiment. What is the first null result is ether drag hypothesis. The second null result is the Lorentz length contraction hypothesis. Listen this one. So ether drag hypothesis says that the ether which is dragged by the all objects moving through the ether media. That means ether media which is ether wind is always attached to the finite mass objects. That's why there is no relative motion between the ether and velocity of the earth. That is the one. Second one, Lorentz contraction hypothesis is the dimension of the object which is contracted by the certain factor. That factor which is equal to the square root of under v square 1 minus v square by c square. This is this factor which is going to dimension of the object which is going to contracted. How much is contracted? Square root of 1 minus v square by v c square. This is the another theory. Okay, I am going to move the next concept. This is according to your syllabus. Okay, Mega, it is clear? Mega? Tejashwini, it is clear? Tejashwini, it is clear? Okay, I am going to move the next concept. Okay, next concept is Lorenzo transformation. Tejashwini, what I am writing on the board? Equations. Lorenzo transformation equations. So here, according to Galilean principle of relativity, this is there are the Galilean transformation equation. X is equal to x minus vt, y dash is equal to y, z dash is equal to z, and finally t dash is equal to t. These are Galilean transformation equations made by Galilean based on mass, space, and time are the absolute quantities. Absolute quantities. What are absolute quantities? The quantities which have the same value for all observers, for all frames. That is we call as absolute quantities. Mass, space, time are the absolute quantities based on Galilean made of the certain position transformation equations, which is equate to the one frame and another moving frame. Therefore, Albert Einstein eliminate this absolute idea of quantities. Therefore, according to Einstein, so here initially what actually we have got this one, T is equal to D dash. This is according to Galilean principle of relativity, according to Newtonian classical mechanics. It is incorrect. It is incorrect. Yes, this is one. And also in addition to this, x dash is equal to x minus vt. This is also incorrect. Yes, this is also incorrect. Therefore, here Lorenzo, what he made based on special theory of postulates of special theory of relativity. So here, base actually the time which is not equal to one frame, another frame. The position what he measured by the one frame which is not equal to another frame, because in the moving frame the dimension of the object which is contracted by a certain factor. That's why Lorenzo equate the transformation equations from one frame to another frame with certain quantity, that is k, it is the constant, with x minus vt. Here k is the constant, and its value depends on v, depends on the value of v. Therefore, according to your syllabus, there is no need to derive. Just to we have write only the expression for Lorenzo transformation equations. I am going to write this is one. After the number of steps, we are going to what actually be the value of k, which is equal to 1 divided by under the square root 1 minus v square by c square. Therefore, I am going to write the Lorenzo transformation equations. X dash is equal to x minus vt divided by under the square root of 1 minus v square by c square. This is the exact form which is going to solve the problems one frame to another frames. This is the first Lorenzo transformation equations. The second, similarly, y dash is equal to y and z dash is equal to z. Finally, we have got t dash which is not is equal to t. Therefore, t dash is equal to t minus vx by c square under the square root of 1 minus v square by c square. These four equations cause 1, 2, 3 and 4 are the Lorentz transformation, position transformation equations. Lorentz position transformation equations. So here, what are the significance of these Lorentz position transformation equations? Biresha, got it, this one? Yes. So here, Lorenzo equate the position coordinates from one frame to another frame with some constant value k. After number of steps, we are going to simplify the value of k is equal to 1 minus 1 divided by square root under the square root of 1 minus v square by c square. Therefore, x dash is equal to x minus vt divided by under the square root. This is we know this is one what actually Lorenzo contraction hypothesis. Y dash is equal to y and z dash is equal to z. Similarly, t dash is equal to not is equal to t. Therefore, t minus vx. V is the velocity of the object. X is the position coordinate from the s frame, rest frame, c square. Again, similarly, under the square root of 1 minus v square by c square. These are the important for the point of examination, maybe chance to appear in the examination for 2 marks. Write the Lorentz transformation equations. Let we know what are the significance. Tejashwini, Geeta, ಸ್ಲೋ ಮಾಡೋಣ ಇನ್ನು ಫಾಸ್ಟ್ ಆಯ್ತಪ್ಪ. ನನ್ನ ಬೋರ್ಡ್ ಅಪಿಯರ್ ಆಗ್ತತಾ ಒಳಗೆ ಸಿರಿಗೆರಿಗೆ? ನಾನು ಅಪಿಯರ್ ಆಗ್ತಿದ್ದೀನಾ? ಹಲೋ, ಫೈನ್ ನಾನ್ ಕಾಣ್ಬೇಕು ಫಸ್ಟ್, ಹೌದಲ್ವಾ? Okay, let me know what are the significance of this is Lorentz transformation equations. So here actually we know this is a t is not is equal to t dash and x dash which is not is equal to x minus vt. Based on this, therefore the first significance, measurement of what is this? Measurement of position and time. Measurement of position and time depends on the frames of reference of the observer. First significance, the position of the particle, the position of the object, the position of the celestial body, which is mainly depends on the frames of the or mainly observer or mainly frames of reference. The first significance which is measurement of position and the time depends on the frames of reference of the observer. Biresh, read it this one. Biresh, read it. See, measurement of time, measurement of position and time depends on the frames of reference of the observer. That means t which is not is equal to t dash, x dash is not is equal to x minus vt. So the magnitude of the time in one frame and another frame is different. The magnitude of the position in one frame and another frame is different. That's why we are going to write measurement of position is depends on the frames of reference. So here second significance, if v is very much less than c, then so here under the square root 1 minus v square by c square which is nearly equal to 1. Therefore, the Lorentz transformation equations which is going to reduced has a Galilean transformation equations, that is x is equal to x minus vt, y dash is equal to y, z dash is equal to z, and t dash is equal to t. This is only valid when v is very much less than c. When v is very much less than c, to solve the problems in one frame to another frame of reference, we use the Galilean position transformation equations. This is okay. Third measurement is the time interval. The time measurement of time interval. The measurement of time interval depends on. So also in addition to this, the measurement of length and the time interval depends on relative motion. These are the significance of Lorentz transformation equations. So here the first significance is measurement of position and time depends on the frames of reference of the observer. Second significance is if V is very much less than C, then what is the factor under the square root? This is 1 minus V square by C square nearly equal to 1. Then the Lorentz transformation equations, which is reduced to as a Galilean transformation equation. These are the Galilean transformation equations. These Galilean transformation equations used only to solve the problems in one frame related to another frame of reference when V is very much less than C. The value of V is very much smaller. Third one is measurement of length and time interval depends on the relative motion. Deepa checked. Deepa? Deepika? Hello? Read it. What actually the third significance? Read it. Read the third significance. Oh, very good. In addition to this, Deepa, listen, measurement of length and time interval depends on relative motion. Okay? Yes. So I am going to move the next concept is this is I am based on third significance. Measurement of time interval. Measurement of time interval, that is equal very important in this case. So here let's see, this is one another important factor, that is yes. So here what actually so far learned according to Newtonian mechanics, or Galilean principle of relativity, T is equal to T dash. What is this? Time measured by the clock in the rest frame exactly equal to the time measured by the clock in the moving frame according to Newtonian mechanics. So here it means two events or events occur in S frame and S dash frame are the simultaneous That means, so here I am going to write this is a 1, this is a 1, 4. So here 1, this is a bulb here, another bulb here. So here at 0 there is a fellow is there, he is going to, what I am writing, Shashank. This bulb from the Shashank exactly 1 meter. In this side, left side, there exactly one, negative side exactly 1 meter. Though this is the position A, this is the position B. So here, suppose a bulb's which is going to blink at once, or a bulb which is go off at once. Because this is one exactly 1 meter from either side, this side and either side. Therefore, Shashank seen by the flash of bulb in because he is the rest. He is the rest frame. He is the rest frame, that is a S frame. Because of S frame is always rest, we consider. Rest frame is nothing but inertial frame. Inertial frame is nothing but there is no external force acting on the object. Then only that frame we call as inertial. Inertial is also we call as Newton's laws are valid in that frame. That frame we call as inertial frame. So Shashank is at rest. So here either side of these two bulbs which is going to blink or a flash, or this one simply we call as the blinking of bulbs or going off exactly same time. Therefore Shashank sees the flash of bulbs which is going to simultaneous because exactly same distance from the Shashank, this bulb B and bulb A. Therefore, the events considered simultaneous in the S frame. The events considered as simultaneous in the S frame. So here, look at this one. Because of this S is the rest frame, or Shashank is at rest. Therefore, what actually the event occurs at the different positions, position A and position B, simultaneously, which is going to measured by the Shashank. At the same time, the two events occur at the same time, which is going to seen by the Shashank simultaneously. Therefore, events considered as a simultaneous in the S frame. The events occur simultaneous in the S frame. So here, the same Shashank, what actually is another illustration we are going to consider, the same Shashank which is going to move towards the bulb B. In this case, which event is going to see the first by the Shashank? Biresh? Biresh. Nodi li? Li. No. What? Listen. Initially, I am going to see this one. Tejashwini? Mega? So here, in the beginning, first illustration, which event is going to seen by the Shashank in the first? Because exactly the same distance. The flash of light seen by the Shashank from both the position, both the events seen by the Shashank is exactly simultaneous. Therefore, in this events occur, consider as a simultaneous in the S frame. What actually the S is? Rest. Shashank is at rest because of this is inertial frame or S frame. So the second illustration is Shashank moving towards the position or a bulb B. So in this case, which event is going to seen the first by the Shashank? Why, Tejashwini? Why? Fantastic. Shashank is moving. We call as a moving frame is a S dash. In the first illustration, T is equal to T dash. That means two events occur simultaneously in both the frame, in both the position. The second is the event is seen by the Shashank is first at the position B. Therefore, here T naught is equal to T dash. Therefore, what actually this is we call as a Relativity of simultaneity. Relativity of simultaneity. I'm going to write on the top of the board. This is a relativity of simultaneity. They may be appear in the examination for 2 marks. Relativity of simultaneity. Mega, read it what I'm writing on the board. Mega, Pooja SP, read it this one. Relativity of simultaneity. So here, according to relativity of simultaneity, what is this here? Two events occur simultaneously. Two events occur simultaneously in S frame. S frame. These may not be occur simultaneously in S dash frame or another frame. This is we call as a relativity of simultaneity. According to Newtonian mechanics, simultaneity is absolute. According to first special theory of relativity, according to Einstein mechanics, the relativity simultaneity is not absolute. That's why relativity of simultaneity means two events occur simultaneously in one frame. These may not be occur simultaneously in another frame. It is called relativity of simultaneity. Yes, this is about relativity of simultaneity. So here, based on relativity of simultaneity, actually this is one according to special Einstein special theory of relativity. According to Einstein special theory of relativity, always eliminate the always eliminated the absolute motion. That's why we have got relativity of simultaneity. Actually, see Albert Einstein, what actually this is one. In S frame, there are its own clock. S dash frame is in the moving frame, the observer having its another clock. Therefore, it is a rest frame, it is a moving frame. Therefore, these two clocks measured that there is a time, exactly there is a time difference. Because it is the rest frame, it is the moving frame. Therefore, the relativity of simultaneity is two events occur simultaneously in the S frame. These are may not be occur simultaneously in the S dash frame. It is called as relativity of simultaneity. So here, today what actually we learned, this is I am going to revision or I am going to glance. This is one. We learn today with three important topics of special theory of relativity. The first topic, which is postulates of special theory of relativity. This is one. The second one is what is the second one? Lorentz transformation. Lorentz transformation equations. Manoj, idea? Manoj? So the second one we learn Lorentz transformation equation and its significance. Third one is relativity of what is third one? Manoj? What is third one, Manoj? What actually the relativity of simultaneity says? What is relativity, sir? Relativity of simultaneity. So according to Einstein, t which is not is equal to t dash. That means the clock measured the time interval between the two events in one frame may not be equal to the another clock measure the time interval between the another frame. Therefore, here two events occur simultaneously in a S frame may not be occur simultaneously in the S dash frame, because S dash frame, it is a moving frame. It is a moving frame. Okay, this is about the today class. Tomorrow I am going to this is one discuss this what is the next important topic. This is Lorenzo Fitzgerald length contraction. Lorenzo Fitzgerald length contraction. Okay, tomorrow I am going to learn this is one. Okay, shall I stop? Any questions on these topics?